My name is Thyresson. I'm going to talk about RIST for high-end live media workflows. And as Net Insight, I think we're one of fewer companies who actually have products ranging from the the high end of the spectrum of products with uncompressed workflows and all those things to the low end side of it with RIST and those kind of things as well. So as a part of that, we have if you look at the topic that we were talking about today here, one thing that we just did in our product lineup is that we introduced a new Nimbra 400 series. I'm not going to stand here and talk about product, but the reason we did that was because internet transport is really converging into the same workflows as we do, as we manage today, with on the uncompressed side and higher end compression schemes. So as a part of that, it really makes sense to just converge everything into one. So what we're going to be talking about today is something as sexy as sequence numbers and how they play a role for high-end workflows. What we're going to go through in a bit more detail is first we're going to look at why this matters at all. We're going to look at what are the requirements for high-end media compared to low-end media. We're going to look at a few of these use cases that are that kind of RIST main profile does support for high bandwidth. And we're going to look at what does this actually mean in practice when we go back to that kind of extended sequence number space that we talked about in the beginning today for those who are here for that, and then just a quick summary at the end. So if we start by looking at the difference in terms of workflows when we look at all the workflows that we support here for media, there is obviously a difference between what we're trying to illustrate here is essentially that there's a connection between the content value, the quality you want, the production budget, and subsequently the infrastructure budget of that equation as well, right? So if you look at, and this may be very simplistic and may be very natural, but if you look at like the extreme high end, let's say you're transmitting Premier League, you have a very high content value, you pay a gazillion for rights. You're bound to have extremely high quality requirements, and therefore you have a high production budget and high infrastructure budget, meaning that you can afford to have very high requirements on that infrastructure as well. If you take the other extreme and you're broadcasting Division 2 of handball in Sweden for a niche audience of 2,000 people, the content value isn't very high, right? Let's be honest. And subsequently, the quality requirements are not that high, production budgets are very low, and the infrastructure needs to be super simple. This was really the use case that when we started to talk about internet transport 5-10 years ago, where this made a really big difference. Right? We started to enable a lot of tier 2, tier 3 content that simply you couldn't do before because it made no sense. Your other option was essentially dedicated fiber or satellite, and none of these really had a cost point that made this viable. Right? The end game in all these cases is obviously that regardless if you have tons of money or not a lot of money, the mission is really the same, right? We want to provide lossless transport over any type of infrastructure in this case. If you look at the high end of the equation, you have dedicated fiber solutions. If you look at like the left side, you have internet transport, and then on the midpoint you kind of have leased lines and business VPNs and those kind of things, right? If we start by looking at dedicated fiber and we look at kind of what are the characteristics that we typically have on that infrastructure, we have an extremely low continuous loss. We are subject to link failure like we typically are on all kind of fixed media. The way we approach that, again, because we have very low continuous loss, is that it's enough to just apply FEC, right? We can apply FEC, and we use methods like hitless protection to run active solutions to minimize any failures or hiccups if we need to switch feed, for example. If we take the other extreme and look at internet transport, we typically have a high continuous loss, and then I'm talking about high continuous loss in broadcast terms, not necessarily in data terms. But even, as many of you know in here, even like a few percentage of packet loss, if you run that unprotected, you're bound to have major hiccups on video, right? We're still subject to link failure, and the kind of approach we're using there is that we use retransmission mechanisms to kind of repair and improve the underlying infrastructure, right? From a protection perspective, we're using bonding typically. And while we're starting to see that we are also using active-active solutions on the internet transport side, typically the reason why we are using internet at all is because we are bandwidth constrained of some sort, right? So the challenge becomes, do I pick 10 meg, if I have a 10 meg pipe, do I pick 8 meg of video, or do I pick 4 meg of video and protect that? That's basically the trade-off that you need to make, right? Now the interesting thing is, like, when you start to approach the leased line space, both these, the internet side of this and the dedicated fiber, start to kind of blend in terms of services, right? So we have kind of a midpoint where we have, low continuous loss. Still, our experience show that even most business VPNs and MPLS connections don't have the quality we need to run dedicated video services unprotected, so we need some sort of protection. Typically, we do that with FEC or retransmission mechanisms, depending on the requirements. Here, we typically do have more bandwidth at our disposal, so typically we do protect that with 2022-7 or hitless protection type mechanisms, right? So why are we talking about these sequence numbers? Well, it's in simple terms, the sequence numbers tells you essentially how many packets can we handle at any given time in the system, right? That means that the sequence numbers altogether kind of form a budget. Now you can use that budget for bandwidth or latency, but you can't do both, right? So if you have a certain buffer, let's say it's 10, you can have a smaller latency and a higher bandwidth, or you can have a higher bandwidth and a lower latency, right? So if we look at like what the changes are in RIST main profile compared to what we had in RIST simple profile, in simple profile we had 2 to the power of 16 packets we could handle, which is 65,000 roughly. In main profile, we've extended that sequence space to 32 bits, meaning it's 4.3 billion, which is significantly larger, obviously, than 65,000. There are other small differences that make the kind of bandwidth not necessarily being exactly 65,000 larger because we have more overhead and so on. But in principle, you could argue it's roughly 65,000 larger bandwidths that you could handle at the same latency. What this actually means in practice is that we are extending the use cases for RIST in this case quite dramatically, right? So if at one point in time we were confined to relatively low bandwidths, we've been doing this for 5 years, and I'd say probably 90% of our deployments are sub 10 megs or sub 15 at least, right? It's MPEG, it's HEVC, typically fairly hardly compressed, right? There's a few cases where we do mezzanine of up to maybe 50 megs, but that's really where we've started to see this tap off, right? Now with RIST main profile, we see this extending quite dramatically, right? We use JPEG 2000, 150 megs. That's not a problem at all. Even a UHD at 300 megs isn't an issue, right? If you look at even lightweight compression, that's certainly doable. And in theory, nothing says we can't do uncompressed. We don't necessarily believe that will be the case, because if you do uncompressed, then you typically have extreme requirements on latency and so on. And even the few milliseconds of latency that you impose here isn't going to be tolerable, right? So in terms of actual applications, what you look at, and we've been doing this for a number of years now, and I think we are fortunate enough to have customers both in the high-end space and in the low-end space, meaning we get people who ask us, why can't we use ARQ for this, so why can't we use RIST for that, right? So if we look at like kind of what we have, traditional use cases that we've addressed, or then I'm talking about 3 here, and I think that the 2 prominent ones are third backup and last mile extension. Last mile extension in this case means that you can use poorer quality connections, or even connections that exists at all, going all the way further out in the network. So instead of having to wait 3 months for dedicated fiber, you can have a connection up and running pretty fast. Now, couldn't you do that before? Sure, you could always do a transcoder or something and use a lower bitrate in the end. one thing that we do quite often is that we bundle services together. We see, customers, they bundle services together in some sort of trunk or virtual grouping, and by doing that, they can look at the operational parameters of an entire bundle, not just necessarily on a per service basis. You also get other benefits with that, such as guaranteeing that you're going to take the same path in the network, and you avoid load balancing and those kind of things as well, right? So what this kind of really enables is it enables better reach, it enables better economy of scale, and faster time to live, to be honest. I think the other really interesting use case, which we're hearing, especially from our larger service providers customers, is third backup. I think it's kind of interesting because when we started to talk about internet transport in the beginning, it was a lot about being that backup link to something else. Now I think over time that's kind of changed, and now we're the primary link in most cases. And now we're kind of seeing that whole thing being repeated again for high-end services, right? So in this case, we can look at customers who have big POPs. They may already have all those POPs being protected by active solutions. We're talking thousands of services running between these POPs. But you know what? Sometimes people dig through both those services, both those fibers, right? And then you're toast. Then you have nothing, right? So by being able to use a third backup, it doesn't even need to be on demand in most cases, and still keep, again, the same operational workflow because it's the same bundle of services you're sending that in that direction instead of what we did before. You get a much better solution. Now, I think the really interesting thing and where internet transport solutions really starts to make a big difference is obviously this, right? Because everything what we're talking about here so far, that's just like how can we optimize existing solutions, right? Guess what? Once you flip the coin and say, wait, I've heard about this cloud thing, people are starting to use that, then how does that work, right? So when you're actually starting to leverage cloud resources, and this is already happening, obviously, for tier 2, tier 3 services, then the bigger question becomes, okay, you need to get your content to those cloud services, right? We're not going to be able to call AVS and say, hey, can we put a Nimbra box in your rack there? Can we put it in the bottom there? Is that okay? I guess the answer is going to be a big FU, right? No, but I mean, let's be honest, this is a software shop, and this is how we need to do that, right? So when the cloud production becomes a reality, and cloud resources is just another resource in a production chain, then the network connection to that cloud is also a part of your standard network. That's just any other network link that you need to handle, right? And if you look at someone may say, but wait, there's, you can buy dedicated business services from pretty much any major cloud provider. And yeah, that's true. But again, those aren't perfect. It's not dedicated fiber. We need to use some sort of repairing mechanisms on those as well in most cases, right? So before we kind of go in and look at, what does this actually mean in terms of numbers, I just wanted to do kind of a quick retransmission 101 here. And the reason for that is not to talk about that specifically, but to talk about the concept of the round trip time, right? Because if we look at this picture here, and we have a source and we have a destination, typically we send a packet from source to destination. Somehow, Batman comes in and ruins that, and the destination says, whoa, I lost a packet, need another one, and the source sends a new packet. That kind of duration takes a round trip time, right? So what we typically recommend is that you need about 5 to 7 round trip times in terms of protection to make sure that you actually have time to re-request packets. So what I'm trying to get at is that there's a clear connection between the latency buffer we can sustain and the underlying network round trip time, right? That makes sense. So if we start by then looking at main profile versus simple profile, and I'm taking a few services here to and try to compare those. I've taken a J2K UHD at 900 megs. I've taken a JPEG XS, so lightly compressed feed UHD, 3 gigs. I've taken a bundle of services, like I talked about before, 15 J2K UHDs, that's 13.5 gig, and I've taken a bit of a forward 18 8Ks, J2Ks, 36 gig. And then we see like what kind of numbers do we end up with when we look at simple profile. Well, in the first case, 900 megs, 760 milliseconds latency buffer. Okay, you're down to a round trip of about 120 milliseconds. That could be doable, right? Especially on business VPN. You increase that to a JPEG XS. Suddenly, your latency buffer is 228 milli, and your maximum sustainable RTT is 45 milliseconds. That pretty much excludes internet connections straight off the bat in most cases. You look at the next example, and we say a group at 13.5 gigs. You're down to requirements of 10 milliseconds. Now it's starting to hurt for real, right? And in this case to the right, we have 4 milliseconds of sustainable RTT, that's pretty freaking hard to achieve, to be honest, right? So with main profile, this changes quite dramatically, of course, right? Because of that multiplication factor of roughly 65,000, as I mentioned before, right? So in the first case, it's 14.3 hours and 3-hour RTT. I'd love to see the network who has a 3-hour RTT, but maybe it's this IP over supersonic carrier pigeon that exists somewhere in the world. Without going through all the numbers, if we get to the end, even like the big bundle of services at 36 gigs, we have a max latency buffer of 21 minutes and 4.3 minutes sustainable RTT, which is, again, it's so high that you're never going to find a real-world implementation. So obviously, we see here that RIST main profile does extend this into realms that are not only sustainable today, but reasonably a number of years into the future. Now, I think one interesting challenge or one interesting aspect with RIST compared to a lot of other protocols we have out there is that since this is based on a technical recommendation and we have a clear specification on how to implement everything, I mean, let's be honest, in our case, if you have a leaf node somewhere out there, we're not going to do 36 gigs in software. We're going to do it in FPGAs, right? And that's kind of really what this kind of opens up versus any software library that you just installed. That's great for many applications, but when you need to ramp up bandwidths, we need to do it in hardware, right? So just quickly before I wrap up in terms of what we do with RIST, obviously we support the RIST working group quite extensively. Michael is involved in the activity group. Alexander here co-chairing the RIST Forum as well. We did the world first interop on main profile. Really excited about that back in August together with QVideum. And what we see is that with the release of main profile that we're going to bring out later this year, we are expanding this to the higher range of our portfolio. We actually already have customers who run beta on this with J2K services of 150 megs. So really excited about how this is going to transform that kind of industry as well. If we just kind of summarize all of this, we obviously see that internet transport is climbing the value chains. It's starting to insert itself into premier applications and much higher bandwidths than we're used to. And the other clear driver here is obviously cloud production. As those resources are becoming more and more used, that kind of extends the network from an on-premise thing to cloud, right? So that cloud link starts to become an integrated part of your network connectivity. And with RIST main profile, this really now opens up for all these higher bandwidth services, whether they are 4K or 8K lightweight compression, or even possibly uncompressed, depending on the latency requirements you have. With that, I'd like to thank everyone for listening and open up for questions. Yes.
So you said that it's like, give me your thoughts about uncompressed over this main profile.
Hmm?
You think that's going to happen, or it's like what?
So I think uncompressed is kind of interesting because I think uncompressed is one of those things that's, if you look at like lightweight compression in comparison, uncompressed actually doesn't give you that much, right? And the reason we run uncompressed is usually that we have quite, we have very high requirements and we have a lot of money. Then we run uncompressed, right? And when you have a lot of money, then you typically don't want any type of disturbance at all, meaning that even just 4 times as much latency may be an issue. I think in all use cases that may not be true, but I think in practice, in reality, in the real world, I think we're going to see that if you run uncompressed, I don't think you'll tinkle too much with this. There are obviously interesting aspects to this, right? And that's like, if you look at things like, I don't think you necessarily run uncompressed, on a least link to AVS. But if you look at on-prem solutions, I just forgot what your on-prem solution is called, but but then suddenly maybe uncompressed is something that you would do, right? Then again, you're in LAN environment, so do you need RIST or not? I don't know. It's one of those things we can, but will we? My guess is as good as yours, I guess. Yes. Hmm?
How do you envisage using that with RIST? If you're say connecting 2 facilities and you need to comply with the timing profiles, particularly the narrow, no chance of narrow and probably wide either. How do you envisage doing that without a converter box in between doing some kind of alignment? But then once you've done that, what's the point in the first place?
Yes, very good question, and I'm not sure that's a very quick answer either. I'm not sure I know it even, to be honest. I mean, obviously, when we thought about 2110 here, it was more like compressed over 2110, not necessarily, uncompressed workflows, where you have to preserve timing and all those kind of aspects. I think still, timing, if you look at 2110 overall and these kind of software implementations that we typically work with here, that's probably the biggest challenge of going into those workflows because you don't get that precision in software that you kind of need, right? Great discussion. Any other questions? Yes.
Among the 3 scenarios you listed on one page, the internet, lease line, and dedicated fiber.
Yes.
For live streaming over public cloud,
Hmm?
the lease line is a popular choice from event side to public data center.
Mm-hmm.
Say X number of miles. If you choose a lease line, you sign contract with a vendor.
Mm-hmm.
Or connectivity vendor. In this scenario, what's the value proposition of using RIST or for the same matter using
Yeah, it may be counterintuitive, but in the discussions that we've had with most customers who have tried to run just straight RTP or UDP over leased lines, simply not good enough because you have shared media and you get bursts and you lose packets and like we video guys know, right? Just a few packets and that's your hiccup in the video, right? It's extremely sensitive. So it's really about, I don't think, unless you have a extremely guaranteed leased line, and those may exist, then you're bound to use some sort of correction mechanisms. Now, would that have to be RIST? No, you could do it with FEC probably, right? But that's the kind of 2 options you have. Just doing nothing, I don't think is an option, to be honest. Okay, thank you.